The most violent volcanic eruption to occur this century was fairly recently. In January of 2022, the eruption of a submarine volcano near the main island of Tonga, about 2,000 kilometres northeast of New Zealand. The eruption of Hunga Tongaunga Ha'api, to give the volcano its full name, constituted an explosion far larger than that produced by any nuclear bomb. It could be heard in Alaska, nearly 10,000 kilometres away. And it generated a tsunami that was 2 meters high even after crossing the Pacific Ocean to Peru. The 2022 Tonga event was undoubtedly a big one, but how does it compare to other volcanic eruptions? I'm James Stewart and you're watching Astrum Earth. In this video we'll look at the volcanic rating scale, ancient clues of supervolcanic eruptions, and potentially dangerous regions across the world. Just how worried should we be about the possibility of future eruptions that are bigger, much bigger than the Tonga event? Let's find out. Geologists quantify the violence of a volcanic eruption using a scale called the Volcanic Explosivity Index, or VEI. Although a given eruption can be assigned a single score on this scale, exactly what score is awarded depends on a combination of factors, such as the volume of rock ejected by the eruption, the height reached by the volcano's ash cloud, or plume, as well as some more qualitative descriptors. The VEI scale is open-ended in principle, but all known events are graded between 0 and 8. Events scoring 0 are represented by eruptions of low viscosity, or runny, lava at volcanoes such as Kilauea or Mauna Loa on Hawaii. Although these eruptions can involve large volumes of material and are dangerous in their own right, they are what geologists term effusive in nature. This means that the lava flows rather than explodes from the volcano's vent. Go up the scale to a VEI of 2 and you reach the sort of eruption represented by the ongoing activity at Mount Etna in Sicily. Keep going, and at a VEI of 3, you get to something like the eruption of Phlegraino Fields, which covered much of the Caribbean island of Montserrat with ash in 1996 and 1997. At a VEI of 4, you reach the 2010 eruption of the Icelandic volcano, its Icelandic name on the screen here for you, whose ash clouds spread over Europe and the Atlantic Ocean, disrupting air travel for several weeks. Because many of an eruption's attributes can't be determined with certainty, there's sometimes disagreement about what score should be assigned to a given eruption. The 2022 Tonga event, with an erupted rock volume of about 1.9 cubic kilometres and a plume that reached a height of 58 kilometres, earns a 5 on the VEI scale by most estimates, although some volcanologists push it up to a 6. This is roughly on a par with the famous 1980 eruption of Mount St. Helens in Washington state in the US. And in case you're wondering what 1.9 cubic meters looks like, it's roughly the volume of a large open pit mine, such as the Mur diamond mine in Russia, or the Bingham Canyon copper mine in the US. Even more violent eruptions than Tonga, those firmly within category 6, include the 1991 eruption of Mount Pinatubo in the Philippines, which caused a small but measurable cooling of the globe due to the aerosols it injected into the stratosphere. And the 1883 eruption of Krakatau in Indonesia, whose ash might have been responsible for the lurid red sky depicted by Edvard Munch in his painting The Scream. A VEI of 7 is reserved for the greatest eruptions in recorded history. These come with the accompanying descriptor super-colossal compared to the merely cataclysmic eruptions like Tonga in the VEI 5 bracket. The most recent eruption rating 7 on the VEI scale was the 1815 eruption of Tambora in Indonesia, which caused tens of thousands of deaths locally and tens of thousands more worldwide due to the volcano's effect on the climate. Because of the ash that Tambora injected into the atmosphere, the following year, 1816, is known as the year without a summer. The average global temperature that year lowered by around 0.5 degrees Celsius, causing harvest failures and food shortages. VEI-7 eruptions like Tambora are few and far between. For another eruption of comparable scale, you have to go all the way back to 1257 and the eruption of a volcano called Samalas, also in Indonesia. But if the largest eruptions in recorded history only reach a VEI of 7, what sort of events could warrant the top rank on the scale? VEI 8 eruptions, given the adjective mega-colossal by volcanologists, are those produced by so-called supervolcanoes. Supervolcanic eruptions involve the ejection of more than 1,000 cubic kilometers of material, more than 20 times the volume erupted by Tambora in 1815, and about 500 times the volume erupted by Tonga in 2022. The huge quantities of material blasted out by these top category eruptions form volcanic plumes that punch high up into the atmosphere, injecting ash and other aerosols that can disrupt the climate for years. Speaking of life-changing eruptions, I had a few of my own to worry about, having suffered from pretty bad acne as a teenager. As a result, I take my skincare now as an adult very seriously, so I'm delighted to say we've partnered with Geology for this video. They're not just some random skincare brand, they're a 41-time award-winning legend in the skincare strata. They've been featured in Men's Health, Esquire, Oprah Daily. There's more layers of accolade in there than a sedimentary rock. It's super simple to get involved. You take a 60-second quiz, tell them about your skin goals, acne, oiliness, wrinkles, a general I don't want to look fossilized, and boom, you get a customized derm design routine delivered straight to your door. I start by using their face wash, which cleans deeper than a fault line, followed by the SPF face cream to keep me hydrated and protected like a well-preserved fossil in amber. To finish it all off, the eye cream says bye-bye to dark under eyes, which means my skin now looks less sandstone and more freshly polished marble. So whether your skin's been through a little erosion or you're just trying to stay igneous and hot, Geology has the tools to keep your skincare solid as a rock. I'm so sorry. Click the link in the description, use our code on screen and get 70% off your personalized trial set right now. Plus, you can grab add-ons at up to 50% off by scanning the QR code on the screen. Don't let your skin go extinct. Go Geology. Thankfully, given their global impact, supervolcanic eruptions are very rare, occurring only once every few tens of thousands of years or so. And the supervolcanoes that produce them are also uncommon, with only about 20 of them known worldwide. This is because supervolcanic eruptions can only occur under very particular geological conditions, where thick, viscous magma that can contain gases under explosive pressures accumulates under the surface in huge volumes. This rareness means that not only have scientists never observed a supervolcanic eruption themselves, but they don't even have any historical records to go on. Instead, like detectives trying to solve a crime with no witnesses to question, they have to work out the processes behind super eruptions by piecing together clues deposited thousands of years ago. So let's run through a few of these geological cold cases. The most recent supervolcanic eruption that scientists know of occurred around 26,000 years ago in New Zealand's North Island. Supervolcanoes don't have the classic cone shape that you might associate with more run-of-the-mill volcanoes. The bodies of magma that feed them are so vast that when the volcano erupts and the magma chamber empties, a huge area of land simply collapses to form a giant crater called a caldera. The caldera created by the most recent super eruption in New Zealand is now occupied by Lake Taupo, 186 meters deep and 46 kilometers across at its widest. The next most recent super eruption is probably one of the most famous. About 74,000 years ago, the Toba supervolcano on the Indonesian island of Sumatra produced one of the most violent volcanic explosions in Earth's history. Like Taupo, the crater left by the Toba super eruption is now occupied by a large lake. But whereas the New Zealand event 26,000 years ago ejected a little over 1,000 cubic kilometres of material, the Toba super eruption 50,000 years earlier involved at least twice the amount, and perhaps many times more. And in case you're having trouble imagining what 1,000 cubic kilometres looks like, try to picture a cube of rock and ash as tall as Mount Everest, and you still won't quite be there. Everest is a little under 9 kilometres tall, but you're in the ballpark. And it wasn't just rock ash that was ejected from Toba in that gargantuan eruption. All magma has various gases dissolved in it, such as hydrogen sulfide, sulfur dioxide, carbon dioxide, and water vapour. In fact, it's the behaviour of these gases that determines how explosive an eruption is. As the magma moves up through the volcano's plumbing system to be erupted as lava, the pressure decreases and the gases come out of solution. If the magma is runny, like that which feeds the volcanoes on Hawaii, the gases can bubble up and escape. But when the magma is thick and viscous, as is the case at Toba and other supervolcanoes, it's much harder for the gases to get out. Now, when the pressure drops, the gases explode suddenly, like a shaken bottle of lemonade when the lid is removed. This blasts the lava into pieces as fine as ash and as large as boulders. So these gases are responsible for pulverizing some of the eruptive material into particles, small enough to linger in the atmosphere for years, shading the planet and lowering temperatures. But sulfur dioxide makes the problem even worse. When it reaches the atmosphere, this gas reacts with oxygen and water to form tiny droplets of sulfuric acid and other aerosols. These aerosols can remain in the stratosphere for as long as a decade, reflecting sunlight back into space and plunging the Earth into a so-called volcanic winter. The super eruption of Toba 74,000 years ago released huge quantities of sulfur dioxide. Although it's difficult to distinguish volcanic effects from background climate cycles, scientists have found evidence that the eruption was followed by a century-long period of cooling. It has also been proposed, based on archaeological and genetic data, that the climatic effect of the Toba super eruption caused our species to pass through a genetic bottleneck. The global population might have dwindled to just a few thousand. This so-called Toba catastrophe hypothesis is contested. Some scientists doubt that the climatic effect of the Toba eruption was large enough to induce a global multi-year volcanic winter, and some question the severity of the population crash that supposedly coincided with it. But whether or not the Toba supervolcano really did cause the population of humans worldwide to shrink to a number that would fit into a large concert hall, if a similar eruption were to happen today, the effects on global agriculture would be truly catastrophic. So how worried should we be? Well, we know that these events are rare. Taupo and Toba are the only super eruptions known to have occurred in the last 100,000 years. If you travel back in time from the Toba event, the next one you would come to is another super eruption of Taupo around 340,000 years ago. But let's not get complacent. At both Toba and Taupo, smaller eruptions have occurred since their most recent super eruptions, and there's no reason to think that their supervolcano is now extinct. Both locations are on the so-called Pacific Ring of Fire, a region of extreme volcanic hazards surrounding the Pacific Ocean, where volcanism is triggered by oceanic crust being forced down into the underlying mantle. Presumably, one day, even if that's in thousands of years, one of these supervolcanoes will erupt catastrophically again. And in the meantime, there are other supervolcanoes to consider. Apart from Taupo and Toba, the supervolcanoes known to have hosted eruptions rating 8 on the VEI scale are clustered in the Andes of Chile, Bolivia and Argentina, and in the western half of North America. Volcanoes associated with the Andean volcanic complex show signs of unrest. Swelling ground suggests a filling magma chamber, for example. but not on a scale that makes geologists think that a super eruption is imminent. The eruptions in North America all originated in a volcanically active region known as the Yellowstone hotspot, which is one of the most intensively monitored volcanic sites on Earth. The geology of the region is complex, and geologists don't know whether the source of the magma is a plume originating deep in the Earth, or a piece of the ocean crust that's been forced under the North American continent. Whatever the origin of the magma, the Yellowstone hotspot is thought to have hosted 6 VEI8 eruptions in the last 10 million years, the last one being approximately 640,000 years ago. These eruptions formed the Yellowstone caldera, now at the centre of Yellowstone National Park. If the supervolcano were to erupt similarly today, it would devastate the states of Wyoming, Idaho and Montana with red-hot clouds of rock, ash and gas moving at hundreds of kilometers per hour. Further from the site, ash would be deposited in a thick blanket, disrupting travel and collapsing the roofs of buildings. And the climatic effect of airborne ash and sulfates would likely be pronounced cooling, of the sort thought to have occurred after the Toba eruption 74,000 years ago, which might have lowered temperatures by several degrees Celsius across much of the world. Because of this threat, and because of the region's long history of activity, scientists continually observe the Yellowstone volcano for signs of ground deformation, earthquakes and volcanic gases, which could indicate magma on the move. The problem is, the Yellowstone region is so active that such occurrences are almost constant. And because nobody has ever actually witnessed the build-up to a supervolcanic eruption, we can't be absolutely sure what we should expect to see before it blows. Based on the average times between the last few eruptions of the Yellowstone volcano, the chance of an eruption occurring there in any given year has been estimated at 1 in 730,000. But that's not really how volcanoes work. They don't hold to schedules like that, so it would be inaccurate to say whether an eruption is due or not. Still, geologists monitoring the Yellowstone supervolcano are confident that there are currently no signs that magma is accumulating in a large enough quantity to feed such an eruption at any time soon. But there are many more sites where huge eruptions have created large calderas, and where a VEI8 event could plausibly occur. And even if an eruption doesn't quite reach the magnitude necessary to qualify for the top category, it could still be locally catastrophic. One such site is the Phlegraino Fields near Naples in Italy. This large complex of calderas lies just across the Gulf of Naples from Mount Vesuvius, the volcano that famously buried the Roman town of Pompeii in 79 AD. While that event might seem bad enough, it scored 5 on the VEI scale incidentally, an eruption of the Phlegraino Fields could be hundreds of times larger. It has been suggested that the climate effect of an eruption about 39,000 years ago helped to see off the Neanderthals, who disappeared from Europe around this time. Although, like the Toba catastrophe hypothesis, this claim is disputed. In the last few years, activity at the Phlegraino Fields seems to be intensifying, with increasing earthquakes and ground deformation causing alarm among volcanologists. Although the probability of a large eruption is still considered very low, the situation is serious enough for authorities to devise an evacuation plan for more than 1 million residents of the area. There is a potential cause for alarm elsewhere in Europe too. The Greek island of Santorini nowadays is shaped like a crescent. When viewed from above with its neighbouring islands, it's easy to imagine Santorini as making up one part of a volcanic caldera many kilometres across. No surprise then, that's exactly what it is. The eruption that caused it was not strictly a super eruption, given its eruptive volume of less than 100 cubic kilometres and its VEI of 7. Nevertheless, this eruption, occurring around 1600 BC, devastated the eastern Mediterranean, generating a tsunami that was tens of meters high when it reached the nearby island of Crete. This explosion could have even contributed to the downfall of the Minoan civilization that was based on Crete, and might have inspired the myth of Atlantis. Volcanic activity has continued at Santorini since then, although no eruption has come close to the violence of that Bronze Age cataclysm. Scientists continue to monitor the region for signs of unrest, and although the question is when rather than if the volcano will erupt, again, there are no indications that a big one is imminent. So how worried should we be about such an eruption in our lifetimes? Well, one day, Santorini, or the Phlegraino Fields, or Yellowstone, or Taupo, or one of the other supervolcano candidates will blow, and blow big. That's a certainty. But it's one of those high-impact, low-probability hazards, like a large asteroid striking the Earth. Although the chances of it happening are low in any given year, it will happen, and when it does, the consequences will be severe. In the case of Santorini, the alarm bells are already ringing after the picturesque island was evacuated in February 2025. According to officials, on Wednesday the 5th of February 2025, more than 11,000 people left Santorini, with around 7,000 departing by ferry and 4,000 people leaving by air, after hundreds of earthquakes rocked the island, the strongest of which was a magnitude 5 tremor. The incident has led to a rapid scientific response, with scientists now investigating for the first time how dangerous the next big one could be. As recently as April 2025, British Royal Research Ship the Discovery, led by Professor Isabel Yeo and her team of 22 scientists, are on a mission to understand what type of seismic unrest could indicate a volcanic eruption is imminent. At the time of recording this video, the team are still on board the vessel, undertaking research in 12-hour shifts as part of their month-long assignment. Hidden amongst the idyllic Greek Isles, some 300 metres below the Discovery, are bubbling hot vents. These cracks in the earth turn the sea floor into a bright orange world of protruding rocks and gas clouds, hydrothermal vents where hot water pours out from the cracks. Off the side of the research boat, a robot descends to the seabed to collect fluids, gases, and snap off chunks of rock in order to try and map the hydrothermal system. They identify how fluid moves through rocks by pulsing an electromagnetic field into the earth. This creates a 3D map that shows how the hydrothermal system is connected to the volcano's magma chamber, where an eruption would come from. This information will create datasets and geohazard maps for Greece's Civil Protection Agency, a member of the government emergency group that met daily during the earthquake crisis. The idea is this research would help inform local people how active the volcanoes are, and it will help map the area that will be forbidden to access during an eruption. Which begs the question, how much notice are we likely to have if it happens on the timescale of our civilization? Will we recognise the warning signs? The worry is that scientists' lack of direct experience of these events might mean they misinterpret what data they have available. Our current knowledge of volcanic explosions has been gathered largely from observing eruptions of volcanoes fed by comparatively small magma bodies, and even then an eruption cannot be predicted with certainty. The 2022 eruption of Tonga, for example, was preceded by about a month of smaller eruptions, and 15 minutes before the big one, an earthquake. But those smaller eruptions were not taken as surefire indications of the imminent VEI5 event, and it was only after the eruption that researchers realised the significance of the earthquake. After all, the largest volcanoes occur almost by definition in the most volcanically active regions, where the Earth shows near constant signs of being unsettled in one way or another. The processes occurring under large calderas could be quite different from those that go on inside the more common volcanoes, making prediction even more difficult. And assuming a supervolcanic eruption could be forecast with confidence a month in advance, as we might argue that the Tonga eruption could have been given our perfect hindsight, that might be long enough to evacuate people from the areas of high impact. But we've seen that such an event would likely have much wider scale, longer term consequences for the climate and agriculture. And to mitigate those effects, even a month is no time at all. Scientists will continue to monitor existing supervolcanoes and to study super eruptions that occurred in the past. If you live in an area like the Phlegraino Fields, where the risk of experiencing a violent, if not supervolcanic eruption is elevated, then you should be prepared to evacuate. All the rest of us can do is hope that the odds of not witnessing one of these cataclysms are in our favour.